So the planning experiment, we did the first 7 questions from this. So what we have to do in this experiment, whenever you're planning experiment, especially in physics, just don't write the whole stories. Just try to answer the bullet points. Okay. So here in this question, a student is investigating the effect of a draught or a moving air on the rate of a cooling. Like how a moving air can affect the rate of a cooling. And we know it's obvious. If higher wind speed is there, the substance on an object will cool down much quicker. The following apparatus is available to the student. An electric fan is there with 4 speeds, a hot water supply, a thermometer, 250 cm cube beaker, and a 250 cm cube measuring cylinder. When you're doing such experiment and different variety of beakers or containers are given, you're not supposed to use all of them. Like throughout the experiment, because you're investigating how wind speed affect the rate of cooling, so you're not supposed to change the type of a container during the experiment. So you have a stopwatch, clamp, boss, and stand. That is for the thermometer. So plan an investigation experiment to investigate how the effect of a draught on a rate of a cooling of a hot water. You should briefly explain briefly how would you carry out the investigation. So we'll answer the first point, how we do this experiment, how we so how it can be done, the procedure. So how the experiment can be done? We will fill the 250 cm cube beaker with 100 cm cube. It's not like you should completely fill with 250. It can be, because 250 is a maximum capacity. So you can have 100, you can have 150. So fill the 250 cm cube beaker with the help of, and try to mention the maximum apparatus which you are utilizing for the experiment, like name of apparatus. So fill 250 cm cube beaker with the help of, so fill the 250 cm cube beaker with 100 cm cube of a hot water by the help of a measuring cylinder. That is the first thing. Now, then what we do? We clamp the thermometer, then place in a hot water, record the initial temperature, then start the timer and use fan speed level 1. Then record the temperature for 3 minutes, usually 3 to 5 minutes. This experiment should be done with the 30-second interval. Like after every 30 seconds, we will record this, we will record the temperature. Then repeat the experiment, different fan speed. So this is a procedure. So how you carry out the investigation, that's the procedure. Now, state the key variable that you would control. What are the variables we should control? What are the parameters that should be same for a fair comparison? Yes. Initial temperature, good. Amount of water, good. What else? Initial temperature, surrounding temperature, amount of a water, volume of a water, the time interval. That's right. So the key variables, the amount of water, the temperature, the time interval, and it is a temperature of surrounding as well as the hot water, both. Initial temperature of the hot water. It is variable, so you should mention minimum to maximum. It can be any number. The next one, draw the table. This, yeah, that's good. Distance of a fan from a beaker. That's right, Mubashir. So distance of the fan from the beaker also affect the rate of a cooling. Then the next one is the table which we draw. So first one is a fan speed. The second one is a time. And the third one is a temperature. You are not supposed to write anything in the any values. Say this is a fan speed. It will be meter per second. And or fan speed level, you can say level 1, 2, 3. Then you will have the time is there. And draw table or table. So what you can do, like you can have for the same tables, you can have 3 or 4 different tables. The first table is for fan speed 1, the second is for fan speed 2, and the third one is for fan speed 3. So here we'll mention a time in second and temperature in degree centigrade. Whenever table is there, table is always with a column heading. So 3 tables you can separately draw. And you can mention this is for a fan level or a fan speed level 1. This one is for fan speed level 2. And this one is fan speed level 3. And then 4 are there, so you can mention 4. How would you use your reading to reach a conclusion? So whenever we reach a conclusion, how we can reach a conclusion? So first, we can plot a graph between the temperature and the time. And the steeper the graph, the faster the rate of cooling. Like you don't have to sketch a graph, you just mention that sketch a graph between the temperature and time. So if you have a steeper graph, means it has a faster rate of cooling. If the slope, a smaller gradient or a slope, it means it has a slower rate of cooling. So this has a higher rate of cooling A because it's much steeper. But you're not supposed to draw this graph. You just mention this point, or you can just label the axis. So mention how you reach a conclusion. We can plot a graph between the time and temperature. Mention where you're plotting a time and temperature, like time on x-axis, temperature on y-axis, and we'll compare the gradient or the slope. The steeper gradient shows that it's a faster rate of cooling. Okay. So that's how we conclude this. Is it clear, this planning experiment? So I want you to plan now this experiment and share your answers.